Yes. We have A2 chemistry, A2 notes, right? So here we have past paper. Last time we have completed entropy, enthalpy, right?
Yes, sir.
Hmm, start from now start from 2020. Yes, 2020, May June variant 41. Describe and explain the trend in solubility of group 2 hydroxide, right? So we have three types of question. In first type, examiner ask about the group 2 hydroxide, and in second type, examiner ask about solubility of group 2 sulfate, and third one is carbonate. So we have three types of question. We have three types of question: solubility of hydroxide, solubility of sulfate, and solubility of carbonate. So let's start from the solubility of hydroxide first. Question is from 2020 variant 41. So always remember that hydroxide solubility increases, sulfate solubility decreases, carbonate solubility decreases. So 4 marks, first point would be solubility increases. Solubility increases. Point number 2, down the group 2, lattice energy and hydration energy both decreases. So point number 2, lattice energy and hydration energy both decreases. Both decrease. Lattice energy, hydration energy both decrease. Less exothermic. Less exothermic. Less negative. Less negative. Point number 3, for hydroxide, always remember lattice energy decreases more. Always remember for hydroxide, lattice energy decreases more. That's why it means hydration energy is more, right? So lattice energy decreases more than hydration energy. Down the group, solubility increases. It means enthalpy of solution become more exothermic. Enthalpy of solution become become more exothermic. More exothermic. More exothermic. This is for group 2 hydroxide. Now move to sulfate. Move to sulfate. Move to sulfate. Yes. Here we have in 2015, October, November, Win 43, discuss the solubility of group 2 sulfate. So solubility decreases. Same answer. Lattice energy and hydration energy both decreases. But this time hydration energy decreases more, not lattice energy. In hydroxide, in hydroxide, lattice energy decreases more. But here hydration energy decreases more. In hydroxide, delta H solution become more exothermic, but here delta H solution become less exothermic. Are you getting my point or not?
Yes, sir. Sir, can we explain this in terms of the structure of sulfates and hydroxides?
Yes, you can. Yes, we can. Now look at here. Uh, so move to the notes, right? Revision or solubility of group 2 sulfate. Solubility of solubility of group 2 sulfate. Solubility of group 2 sulfate. Now look at the structure of this is beryllium. This is beryllium sulfate, magnesium sulfate, calcium sulfate, strontium sulfate, barium sulfate. Solubility decreases. Solubility decreases. Now consider beryllium sulfate. This is beryllium 2 and this is sulfate. This is minus. So This is beryllium, right? Now here we have barium. Barium plus 2, sulfur minus, oxygen minus. Now, can you tell me what about the latest energy? Down the group size increases. So latest energy increases or decreases?
Sir, it decreases.
So point number 1, latest energy decreases as size increases. Decreases means less exothermic, less negative. Point number 2, hydration energy. Yes, as the size increases, you know that hydration energy also, with the latest energy decreases.
Decreases.
Okay, hydration energy also decreases. Because you know that as the size increases, hydration energy decreases. As size increases. So less exothermic, less negative. Less negative. Now next is, which one decreases more? Which one decreases more? Latest energy or hydration energy? So it is a
Sir, for
fact. Yes, yes, tell me.
sir, hydration energy decreases more for sulfates.
Okay, hydration energy decreases more. Which one is increasing? If hydration energy decreases, latest energy increases.
No, sir,
If
both
lat
will decrease.
both will decrease, both will decrease. Now listen again my question, right? Both are less exothermic, less negative, right? Right? Both are less exothermic, less negative.
Yes, sir.
Okay. So now my question is that release energy, both are release energy, right? So you know you told me that hydration energy decreases more, right? Hydration energy is less exothermic. Let's suppose latest energy is, let's suppose latest energy is 500 kilojoule per mole. Assume value, right? Here latest energy is 250 kilojoule per mole, right? So can you tell me the difference? Difference is 250 kilojoule per mole, right? Now, now look at the hydration energy. Hydration energy. Here we have, let's suppose, 400 kilojoule per mole, right? So here hydration energy, all are negative, all are negative, all are negative, all are negative. So here hydration energy would be 100 kilojoule per mole. Now, can you tell me the difference of the hydration energy?
Sir, one.
Here latest energy is 250 difference, but hydration energy difference is 300.
350
300.
kilojoule
Okay,
per mole.
kilojoule per mole. So which one decreases more? Just can you tell me which one decreases more? Latest energy or
So,
hydration energy?
hydration energy, sir. Hydration energy.
Hydration energy decreases more and latest energy decreases less. So who win the race? Latest energy or hydration energy? Which
Hydration
one has
energy.
which one has less decrease?
What's the latest energy, sir?
Latest energy. So latest energy won. It means solubility decreases because latest energy is responsible for the stability of the soil of the salt. If latest energy is more, if you have less decrease in latest energy, it means salt is more stable. Or in simple language, if hydration energy is more in any salt, if hydration energy is more, we compare the hydration energy with the latest energy. If hydrogen energy win, it means salt is soluble. If latest energy win, it means salt is insoluble. Are you getting my point or not?
Yes, sir.
So here hydration energy decreases more. And you know that delta S solution is responsible for the solubility of any salt. If more exothermic, more soluble. So delta S solution is less exothermic down the group. Same answer, same for the solubility of hydroxide. This is for group 2 hydroxide. 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 Solubility increases. Here solubility increases because you know that hydroxide has the tendency to make hydrogen bonding with water. That's why solubility increases. Here we need 2OH. Here we need 2OH. So let's suppose now change the values. Here we have hydration energy. Here we have latest energy. Here we have hydration energy. Here we have latest energy. So this is delta H, hydration energy. Here we have delta H, latest energy. So this time latest energy decreases more. So both decreases, latest energy decreases. Same point. So hydration energy also decreases, but here latest energy decreases more. Latest energy decreases more. Delta H solution is more exothermic. More exothermic down the road. That's why solubility increases. Are you getting my point or not?
Yes, sir. But sir, for hydroxides, they can form hydrogen bonds with water, right?
Yes, yes. That's why solubility. That's why uh, hydration in latest energy decreases more, and or you can say that hydration energy increases more. Increases increases more. Yes,
Okay, sir.
or you can say that latest energy is
सर
less exothermic. Yes, yes. बेटा पूछे.
सर डिजीज का ये है कि वो से ज़्यादा
मुझे आपकी बात समझ नहीं आई. कैन यू रिपीट?
मतलब क्या जी मैं ये कहना चाहती हूँ कि ज़रूरत लेट से में कोई चीज़ आ रहा है लेट क्या उसका इंक्रीज है वो होना चाहिए और रीड कर
आपकी आवाज सही नहीं आ रही है. मैं इसको रिपीट करता हूँ. मैं आपको इसको रिपीट करता हूँ. अब ऐसा रीजन क्या है? देखिए इन्होंने ना मार्किंग स्कीम में ऐसा लिखा है, वरना कसम से मैं ऐसा लिखवाता नहीं. मैं आपको सिंपल लिखवाता कि भाई डाउन द ग्रुप लेटेस्ट एनर्जी जो है वो हारती है, हाइड्रेशन एनर्जी जीतती है. दैट्स व्हाई हाइड्रोक्साइड सॉल्युबिलिटी ऑफ हाइड्रोक्साइड इंक्रीजेस. अब वो क्यों ऐसा होता है? बिकॉज ऑफ द हाइड्रोजन बॉन्डिंग. हाइड्रोक्साइड कैन फॉर्म हाइड्रोजन बॉन्डिंग विद द वाटर. बोले बात समझ आ रही है?
सर रिपीट कर
मैं ये कह रहा था कि हाइड्रेशन एनर्जी जो है वो अगर जीतेगी, if you have more hydration energy than latest energy, salt becomes soluble. If latest energy is more, salt is insoluble. In hydroxide case, hydration energy is greater than latest energy down the group. But in sulfate and carbonate, hydration energy is less, latest energy is more. That's why salt is insoluble. अब ऐसा होता क्यों है? ऐसा इसलिए होता है क्योंकि OH पानी के साथ हाइड्रोजन बॉन्डिंग बना सकती है, सल्फेट नहीं बना सकता. बिकॉज ऑफ द हाइड्रोजन बॉन्डिंग, हाइड्रोजन एनर्जी इज मोर. आपको समझ आया?
रेशन की जो वैल्यू है वो लैटिस की वैल्यू से ज़्यादा
नहीं, मैंने ये दिखाया है कि इनका डिफरेंस ज्यादा होगा, डिक्रीजेस, ज्यादा तब्दीली आएगी. वो मुश्किल बात है जो मार्किंग स्कीम में लिखी है. मैंने आपको बहुत क्लियर बात बताई है कि हाइड्रेशन एनर्जी ज्यादा
जो है
होगी.
वो कैसे वो डाउन
हाँ बोले क्या? आप एक काम करें ना, मुझे व्हाट्सएप कर दें अपना क्वेश्चन वॉइस नोट में, मैं यहाँ सुन लेता हूँ. आलिया, आपको मेरी बात समझ आ रही है? आर यू गेटिंग माई पॉइंट्स?
जी सर.
मैं दोबारा रिपीट कर लेता हूँ, उसके बाद हम आगे बढ़ते हैं पास पेपर की तरफ. कि as down the group 2, either you have hydroxide or sulfate. Hydroxide has the tendency to make hydrogen bonding with water, not sulfate. Because of the hydrogen bonding, because the hydrogen bonding, hydrogen energy is greater down the group. Tendency to form hydrogen bonding increases down the group. That's why group 2 hydroxides are more soluble down the group and sulfates are not soluble down the group. अब हम वापस आते हैं पास पे. चलिए जी, क्वेश्चन नंबर 29 से स्टार्ट करते हैं. Suggest a reason why the delta H values for the two equilibria are very similar. ये क्वेश्चन है हमारे पास 2016 मई जून वेरिएंट 42. 2016 मई जून वेरिएंट 42. बोले क्वेश्चन देखें और बताएं व्हाई डेल्टा एच वैल्यूज आर फॉर द टू इक्विलिब्रिया आर वेरी सिमिलर. Alia, are you listening to my voice?
So both are equally exothermic.
The question is that suggest a reason why delta H values for the two equilibria are very similar. Always remember that delta H depends on bond breaking and bond forming, right? So here we have in reaction in equilibria 1 4 bonds with cadmium, and in this case you also have 4 bonds. Why? Because you have 2 NH2. So 1 NH2 form 1 bond. So totally you have 4 NH2. So total number of bonds in both the equilibrium are same. Now look at the structure. This is cadmium. You have 4 CH3 NH2. 1, 2, 3, 4 dative bonds. So we will discuss this type of dative bond in transition chemistry. So now you can see that 4 bonds. Four bonds. Similarly, in the next one, you have cadmium. You have cadmium. Again, you have 4 bonds. This is NH2, CH2, CH2, NH2. So again 4 bonds, NH2, NH2, CH2, CH2. So in both the case, same number of bond form, or you can say that 4 nitrogen cadmium bond form in both reaction. In both reaction, 4 carbon, nitrogen, sorry, cadmium, nitrogen. Bonds are formed. That's why they have same delta H value. Are you getting my point or not? Yes?
Yes, sir.
Now next, calculate delta S for equilibrium, delta S. So all the values are given, just use the formula. Delta G is equal to delta H minus T delta S So delta S is equal to delta H minus delta G over T. So delta H is minus 56.5 minus delta G is 60.7 divided by temperature is 298. 298. Now can you tell me the answer?
सर एंथैल्पी
Sir, zero.
कन्वर्ट करना है ना
Entropy, both are in kilojoules, right? But you need the answer in joules per Kelvin, right? Can you tell me the answer?
Sir, 0.393.
Are you sure?
मेरा 0.0
0.0
14
0.014. Next 0.141.
0.1
141, right? This is kilojoule per Kelvin per mole, but you need in joules. So multiply it by 1000. Your answer would be 14.1. So positive 14.1. Next question. Suggest a reason for the difference between the delta S you have calculated 14.1 for the equilibrium 2 and that of the equilibrium 1 given the table. Minus 66.8 and here you have positive. Can you tell me why it is different and what is the meaning of the different value? Yes, Alia.
one show equation
One is negative, second one is positive. Why?
Sir, equilibrium 1 is more disordered.
Hmm. So you know that if the entropy value is low, right? Low value means more stable. So which one has more delta S? Equilibrium 1, equilibrium 2.
So equilibrium 1.
Equilibrium 1 has less value, 66.8 minus, and equilibrium 2 has plus 14. So plus 14 is greater. Plus means increase, negative means decrease entropy. So which one has increased entropy? As the entropy increases, stability increases. As you know that solid is more stable than gas. Yes. Which
इक्विलिब्रियम
one has?
आना क्योंकि उसकी कम है मतलब है वो ज्यादा
देखो मेरी बात सुनो, देखो मेरी बात सुनो. एंट्रोपी मीन्स डिसऑर्डरनेस. ठीक है. जिसकी डिसऑर्डरनेस ज्यादा होगी, जिसकी डिसऑर्डरनेस ज्यादा होगी वो स्टेबल कैसे हो सकता है? मतलब जिसमें डिसऑर्डरनेस ज्यादा इंक्रीज हो रही है वो स्टेबल हो ही नहीं सकता, वो तो लेस स्टेबल होगा। जिसकी इंट्रोपी की वैल्यू कम होगी। अच्छा, इसी तरह से गिब्स फ्री एनर्जी है। आप गिब्स फ्री एनर्जी करके बता देना, इसमें लिखा है सजेस्ट रीजन फॉर द डिफरेंस बिटवीन द डेल्टा एस यू हैव कैलकुलेटेड फॉर इक्विलिब्रियम 2 एंड दैट ऑफ इक्विलिब्रियम 1 गिवन इन टेबल 1। वो पूछा इसका डिफरेंस बता दो भाई, डिफरेंस क्यों है? व्हाई इक्विलिब्रियम 2 हैज 14.1, इक्विलिब्रियम 1 हैज -66.8। Now you can see that here we have 5, 1 is formed. Here we have 3, 1 is formed. So where is more disorderness? Where is more decreased? Or which salt is more stable? Where is fewer mole? Now here fewer moles of solute are formed one mole of fewer mole of solute are formed fewer moles fewer moles of solute are forming one mole of the complex. So less loss of disorderness. For example, equilibrium 1 delta S is -66.8. In equilibrium 2 delta S is plus 14.1. Fewer mole of solute are forming the complex, so less disorderness. In equilibrium 1 more molecules form 1. That's why entropy is negative. In second equilibrium, total 3 mole gave one product. So in equilibrium 2, there is slight change, but in 1, change of 4. That's why entropy is negative, and in second, entropy is positive. Are you getting my point or not? Alia?
Yes, sir, I'm getting it.
So fewer moles of solute are forming, means 1 mole, right? So less loss of disorderness. In equilibrium 1, we have 5 mole, 5 to 1, more decrease in entropy. But in second, 3 convert into 1, so less disorderness. Entropy is positive. Now second, which of the two complexes is more stable? Which one has more delta G? Which one has, yes? Beta, which one has more delta G? Second
Sir, 2.
equilibrium has, yes, exactly, 60.7. So cadmium NH2, CH2, CH2, NH2 is more stable. It most stable because delta G is more negative. Yes, delta G is more negative, more exothermic. So that's why second is more stable. Or you can say that the equilibrium value is more. It also have high K equilibrium or K stability. We will discuss K stability in transition chemistry. So K stability means Kc.
डेल्टा जी पता चलता है
देख, हाँ बिल्कुल सही कह रही हो। देखो मेरी बात याद रखना, ठीक है। डेल्टा जी जितना ज्यादा पॉजिटिव होगा, ठीक है, तो उतना डेल्टा जी की बात हो रही, उतना ज्यादा फिसिबिलिटी होने के चांसेस कम होते हैं, ठीक है। तो ऐसे ही कुछ इसका आंसर है। चलिए उल्टा चलते हैं। चलिए लास्ट को, इसका लास्ट वाला पार्ट है 2023 का। The standard enthalpy change of solution of AgNO3 in water is 22.6 kilojoule per mole. Suggest how the feasibility of dissolving AgNO3 is in water changes with temperature. Explain your answer for 2 marks. Yes, bete. Tell me the answer. Any idea? बेटा आपको मेरी आवाज आ रही है, नहीं आ रही है? मुझे कुछ समझ ही नहीं आ रहा है। आर यू लिसनिंग माय
Sir,
वॉइस?
yes, sir.
हम्म,
Sir, delta H is positive, so when the temperature will increase, delta T delta S will become more negative. So delta G will also be more negative, so it will become more feasible.
हम्म, ओके। बेटे आप बताएं इसका आंसर क्या होगा?
डेल्टा एच सॉल्यूशन एज अ रिजल्ट
हम्म,
डेल्टा
हम्म,
का मतलब ये होगा कि टेम्परेचर
ठीक है, सही है। और थोड़ा सा एलोबरेट करेंगे इसे। बोले इसको थोड़ा सा।
टेम्परेचर को सपोर्ट फॉरवर्ड को तो एज अ रिजल्ट जाएगा वो पॉजिटिव है तो
अच्छा
इंक्रीज
ठीक
हो
है।
जाएगी
देखो पॉजिटिव का मतलब तो ये हुआ कि ये
इंक्रीज हो
एंडोथर्मिक है।
जाएगी
हाँ, पॉजिटिव मींस ये एंडोथर्मिक है, ठीक है। तो डिसॉल्व इन वाटर विद टेम्परेचर, तो क्या सॉल्बिलिटी बढ़ जाएगी?
जी इंक्रीज कर दिया।
अच्छा, मेरे ख्याल में मुझे खुद कराना चाहिए। ठीक है, तो अब आगे बढ़ते। ये कह रहा है कि भाई आपको ये बताना है कि द स्टैंडर्ड एंथैल्पी चेंज ऑफ सॉल्यूशन ऑफ HCl इन वाटर इज प्लस, सजेस्ट हाउ द विजिबिलिटी बताना है, डेल्टा जी के हवाले से बताना है। तो राइट द फॉर्मूला, डेल्टा जी इज इक्वल टू डेल्टा एच माइनस टी डेल्टा एस। Now listen, if you increase the temperature, T delta S increases because it has positive value. As you increase the temperature, T delta S increases. If you increase the temperature, T delta S increases. T delta S is positive. So if you increase the temperature, T delta S become more positive. Whenever T delta S become more positive, delta G become negative. Because when T delta S increases, it means negative increases. Are you getting my point or not?
सर
जी जी बोले। यस,
सर जो ये 22.6 की वैल्यू है ये डेल्टा एच है डेल्टा एस है।
दिस इज डेल्टा एच। ओके ओके, दिस इज डेल्टा एच। आई एम सॉरी, enthalpy change of solution, I am sorry. Now listen again, delta S is not given, delta H is given. Delta S is not given, delta H is given. Okay, this value is positive, this value is positive. When you increase the temperature, again this factor increases, so again delta G would be negative. So delta H is positive, delta H is positive, delta H solution is given. Solution is not given. Okay, so delta H is positive. As temperature increases, as temperature increases, as temperature increases, T delta S become more negative. T delta S increases, T delta S increases, become positive, become positive. Hence, delta G will be negative. Visibility increases. Visibility of the reaction increases. Beta, are you getting my point?
यस सर।
Now, this one. Complete the electrons in box surface diagram to show the electronic configuration of zinc plus zinc 2 ion. So zinc is 30, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. When two electrons are removed, so electronic configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d10. So how many electrons would be in 3d? Yes,
Sir,
Bete, how
10.
many? 10. So this is argon. This is argon 18. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be the electronic configuration of zinc plus 2 ion. Now this question, calcium chloride 2022 October November, variant 42. 2022 October November, variant 42. Yes, what is latest energy? Bete, what is latest energy?
So it's the enthalpy change when 1 mole of an ionic solid is formed from its gaseous ions under standard conditions.
Okay. When 1 mole of ionic solid is formed, when 1 mole of ionic solid is formed from gaseous ion, from gaseous ion. This is the enthalpy change, right? Is it correct?
Yes, sir.
Okay. Now second question, use data in table 1.1. Calculate the delta HF of calcium chloride. So first draw the calcium solid. Calcium solid convert into calcium gas. Then calcium gas convert into calcium plus. Then calcium plus 2. Now tell me the H1. Then H2. Then H3. Yes, look at the question and tell me the H1. Which one is H1?
Also atomization of calcium, so 193.
193. And what is H2?
So 590.
Plus 590.
Okay. 590, 590. And what about the second?
Electric.
Second ionization energy is 1150. So now second is chlorine. Cl2 gaseous. So we need 2 chlorine. 2 chlorine minus gaseous. This is H4. Yes, can you tell me the value of H4?
So 121 divided by 2 times 2.
No. Whenever atomization is given, just write the 121 multiplied by 2 because two atoms are formed. Whenever bond energy is given, bond energy divided by 2 multiplied by this number. Are you getting my point or not?
Okay, sir.
Now this is 121. Now combine these two. This is atomization. Now convert into chlorine minus 2. This is H5. Can you tell me H5? Yes.
Sir, two
Elect
times
2 times. Very good. 2 times. Very good. Minus 364. 364. Now combine these two ions. CaCl2 solid. This is H6. This is H7. H7 is required. Yes, can you tell me latest energy?
So minus 2237.
Minus 2237. Right? So formula would be H. Yes. Formula would be H1, H2, H3.
Sir, it's 7.
H7. Very good. H7 is equal to H1. हमेशा formation is equal to sum of all enthalpies. H4 plus H5 plus H6. So H1 is 193. H2 is 590. 1150 plus 2 times 121 plus 2 times minus 364 plus minus 2237. Now tell me the answer. Yes. Minus
7.
790. Minus 790 kilojoule per mole. Now next question. Three possible values for the first electron affinity of bromine are shown in table 1.2. One of them is correct. Yes. Can you predict the electron affinity of bromine? So first look at the electron affinity of chlorine. Electron affinity of chlorine is minus 364. Minus 364 kilojoule per mole. So can you predict the electron affinity of bromine? Either it is equal to or greater than. Yes. Down the group size increases, attraction decreases. So electron affinity increases, decreases.
Increases.
Electron affinity decreases. because down the group size increases. As the size increases, nuclear attraction decreases. So released energy decreases. So which one is less than 364 minus 342? Because size of bromine is greater than size of chlorine. Size of bromine is greater than size of chlorine. As size increases, nuclear attraction decreases. Electron affinity also decreases. Less attraction, less energy is released. Are you getting my point or not, bete? Bete, are you getting my point or not?
Oh, yes, sir.
Okay, next question. Standard enthalpy of solution is given, hydration is given. And then examiner asks, define enthalpy of solution, enthalpy of hydration. Yes. Can you tell me the definition of hydration and solution?
So the first one is the enthalpy change when water is added in 1 mole of ionic solid to form aqueous ions.
To form aqueous ion and form dilute solution, right? Now, solution. Enthalpy change when 1 mole of ionic solid dissolve in water to form aqueous ions. And what is hydration? Just what is hydration?
Sir, enthalpy change when 1 mole of gaseous ions dissolve in water to form a dilute solution.
Enthalpy change when 1 mole of gaseous ion gaseous ions dissolve into aqueous ion, right? To form dilute solution. Dilute solution. Now next part, calculate the standard enthalpy change of hydration of the chloride ion. So we know that Hyderabad is equal to Lahore plus Sakkar. It means hydration energy is equal to latest energy plus solution. So in salt is calcium chloride. So delta H hydration of calcium plus 2 times delta H hydration of Cl minus, because you have 2 chlorine atom. Latest energy plus delta H solution. Now put the values. Hydration of calcium is minus 1650. Minus 1650. Hydration of chlorine is required. Latest energy, you have calculated latest energy minus 790. Minus 790. Solution is minus 83. Now, can you tell me the value of X? But the latest energy is 83 minus 790. Latest energy is 2237. Sorry, minus 2237. Minus 2237. And the solution is minus 83. Yes, now calculate. Minus 2237 minus 83 plus 1650 divided by 2. Yes,
So minus 335.
minus 335 minus 335 kilojoule per mole. Now, next question. This question is from 2022 October number variant 41. Now complete the energy cycle involving the enthalpy change of solution and the latest energy of potassium chloride. Now here you have potassium chloride solid, right? So first convert into potassium solid, sorry, potassium aqueous, Cl negative aqueous. This is called delta H solution. Delta H solution. So right here K positive gaseous plus Cl negative gaseous so this is called delta H hydration. Hydration or latest energy, please. Can anyone tell me this is hydration energy or latest energy?
Sir, latest energy.
Yes, this is latest energy. But when you add water in it, gaseous ions are formed. This is called delta H hydration. This is hydration.
Yes, sir.
Because this is hydration. Okay, try to make two arrows, right? One from potassium to potassium. Because hydration for cation and anion both are different. This is delta H hydration of K positive. This is delta H hydration of Cl negative. Now calculate the enthalpy change of hydration of magnesium ion. Show your working. So all data are given. So just use hydration energy is equal to latest energy plus solution. So hydration energy of potassium plus delta H hydration of Cl minus is equal to latest energy plus solution. So hydration energy of potassium is, I think, required. Yes, hydration energy of potassium is required. Hydration of chlorine is minus 364. Latest energy is minus 701. Enthalpy of solution. Enthalpy of solution of potassium chloride. Can you tell me the value of potassium? Enthalpy of solution plus 15.
Sir,
Yes.
so we are doing this for the magnesium ions, right? So
For
then why
magnesium
we
ion?
using -0 1?
Oh. Yes. This is for the magnesium ion, not for the potassium ion. So this used salt is MgCl2. So here we have magnesium. Magnesium plus 2 and 2 times of hydration of chlorine. Now tell me the value of hydration of magnesium. So I think hydration of magnesium is required. So right here X. Hydration of chlorine is given. Minus 364. Latest energy of magnesium chloride is minus 2493. Minus 2493. And solution of MgCl2 is minus 155. Minus 155. So X is equal to, yes,
So -1920 then.
2 6 are 12, 2 7 7 28. Okay. Minus 2493 minus 155. So X would be minus 2493 minus 155 plus 728. So X, beta, please tell me the answer.
So 1920 minus
19
1920.
1920. Hydration is always minus. So minus 1920. Now explain the reason why latest energy of MgCl2 is more exothermic than KCl. So here we have MgCl2, here we have KCl. So which element is cancelled out?
So chlorine.
Chlorine is cancelled out. So now you have magnesium plus 2, K plus. So you know that latest energy is directly proportional to charge. So which one has more charge?
Magnesium.
So the latest energy of magnesium chloride is more. So because magnesium has more charge +2 than potassium +1. Then potassium +1. If magnesium has more charge, so a strong electrostatic force of attraction, strong electrostatic force of attraction between magnesium +2 and Cl minus, then K positive and Cl minus. Are you getting my point or not? This is for 2 marks. You can also write the size, right? Size of the magnesium is smaller. Beta, are you getting my point or not?
Yes, sir.
Now define the following term. Yes, enthalpy change of atomization. Yes.
So enthalpy change when 1 mole of gaseous atoms is formed from the element under standard conditions.
No need to say standard relation because there is no standard enthalpy change of atomization, right? So enthalpy change, but you can write enthalpy change when gaseous atom is formed. When gaseous atom is formed, enthalpy change when 1 mole of gaseous atom is formed from element. So element may be gaseous, may be solid, may be liquid. So it is necessary to write in standard state. In its standard state, you are right. In standard state. Now next is, yes, electron affinity. Yes, what is electron affinity? First electron affinity.
So enthalpy change when 1 mole of electrons is added to 1 mole of gaseous atoms.
Very good. Enthalpy change when 1 mole of, same definition, gaseous, when 1 mole of gaseous atom then gain electron, 1 electron to form gaseous -1 ion, to form gaseous -1 ion. Okay. So we have, I think, So now what are your opinion? Should I start in the next class new chapter or do more past paper question? Yes.
Please do a question through the notes ताकि मेरा पूरा रिवाइज हो जाए review.
अच्छा मेरी बात सुनो तुम, मैं ये कह रहा था अभी इस वीक में ना मैं एक एक्स्ट्रा क्लास रखूंगा पास्ट पेपर की, ठीक है? तो वो मैं आपको लिंक भेज दूंगा दोनों को, तो अगर आप बोलेंगे तो अगर नहीं ले सकते तो फिर मैं रिकॉर्डिंग करके भेज दूंगा। ये पास्ट पेपर की प्रॉब्लम्स कराएंगे, ठीक है? इफ यू हैव एनी क्वेश्चन रिगार्डिंग एनर्जेटिक यू कैन आस्क, वी हैव अ लॉट ऑफ क्वेश्चन इन इट। आपको मेरी बात
सर
समझ आ
आप
रही है?
दिखा सकते हैं
क्या चीज दोबारा बोलना?
सर वो नोट्स सकते हैं आपने जो
मैं
कल
वो मैं अब वो
स्क्रीनशॉट
चैप्टर हाँ हाँ वो चैप्टर खत्म हो गया ना, आज मैं तुम्हें ये नोट्स भेज दूंगा ग्रुप में, दोनों को भेज दूंगा इंशाल्लाह, ठीक है?
और
चलो
सर
ठीक है
ये
हाँ
लैबोरेटरी का मुझे चेंज पता इनके चेंजेस और सॉलिडिटी कैसे इफेक्ट.
अच्छा तुम्हें मैं और बात है, मुझे तुम्हारी आवाज कट कट के आ रही है ना, कुछ समझ क्लियर ही नहीं आ रहा। तुम एक काम करो, ये क्वेश्चन मुझे व्हाट्सएप पे पूछो, मैं तुम्हें व्हाट्सएप पे वॉइस नोट भेज देता हूँ, ठीक है? ठीक है चलो ठीक है, चलो बेटा अल्लाह हाफिज।
Okay, thank you, sir. Allah
सही
Hafiz.
बेटा अल्लाह हाफिज।